Alrighty, now we're starting part C of free response question 3 of the AP Calculus exam. And what we want to do here is when we read it, is there separation of variables? And immediately I'm thinking we need to use separation of variables. This is the differential equation and it mentions a particular solution. Where's my points here? They give it to us at 0, 4. And that's going to be very important. So first thing first, we need to separate before we integrate. So as we separate this, we're going to bring down the h minus 1, right? So the h minus 1 comes down here, then we're going to integrate. And then we're going to keep everything else on the other side, but move that dt up. So once we do that, now is actually time, the fun part, the integration. Now, I didn't show all of these steps, but you all should be thinking u substitution. Yes, and when we do our u substitution here, we're going to end up getting u is going to be equal to h minus 1, and our du would be equal to 1, or dh, whichever one you want to call it there. So that's what we will end up getting. So we get a dh there because the derivative of h is going to be 1. Therefore, we get ln. This would be 1 over u, ln of h minus 1. Perfect. Same thing here. We got another u sub. My u is going to be t over 2. And t over 2 is going to be equal to 1/2 dt. Now, that 1/2 dt is going to become a 2, and that 2 is going to cancel out with this 1/2. So that goes away. Boom. Because it's 2 times 1/2. So we end up integrating. What's the integral of cosine? Sine. And then we plug back in u. We get t over 2 plus a c. Don't forget about our plus or c. Now, we have to find and plug in 0 and 4 to get what our c value is. That is 100 important. That's 100% an important step. Don't forget that. We end up getting ln of c. We plug in 0 for our t and we plug in 4 for our h. We get ln of 3 equals c. Now we plug it back in. Don't forget that this e raised to the ln cancels. So we just get a 3 here. And then lastly, we add 1. That is our final answer. Perfect. Now, don't forget in these steps here, this one didn't have that, but what we will want to do is plug in 0 here to make sure we in fact get 4. We do 3, because this would be 1. 1 times 3 is 3. 3 plus 1 is 4. This works, but you always have to check just to make sure when we're doing a differential equation.